Good morning students, this is Joy Varghese from Uncovering Chemistry. Today in video 18, unit 1, basic concept of chemistry, we are going to discuss about textual numerical, that is 1.24, 25, 29. 1.31 is homework for you because we have already discussed our significant figure. 1.32, 34, 35 and 36. Clear? So we are going to discuss these numericals today. Okay, so we'll start with the first one, that is 1.24. Now 1.24, when you see in your textbook, what we see here, you can see dinitrogen and dihydrogen reacts with each other to produce ammonia according to the following chemical equation. N2 plus H2, what does it give? 2NH3, right? Now this is the same example of limiting reagent. What we are going to talk about, that is remain unreacted. So we are talking about this example is of limiting reagent. Right, so how this already we have discussed limiting reagent from your textbook solved example. That same question it is, but in different things are given that we will go through it. Okay, just a minute. Okay, now in your question it is given that N2 is given, how much it is given as 2.00 into 10 raised to 3 grams. Now 10 raised to 3 means 1000, so 2 into 1000 means we can write it as 2000 grams. N2 is given. Okay, same way hydrogen is given 1.00 into 10 raised to 3 gram, so that is equal to 1000 grams, right? Because 10 raised to 3 means 1000, what we say. Understood? So these two things are given for a given reaction, that is what N2 plus 3H2 gives you what? 2NH3, right? Like this, what we say. Now for the first question, when we say, the first question is calculate the mass of ammonia. What is the first question? Calculate the mass, what we say, the mass of ammonia. Ammonia. Clear? Ammonia means NH3. For this mass you have to calculate. So first of all we'll find out, same way, will any, second question is, will any two reactants, you can see in this, what is written here, will any two reactant remains unreacted? So from this limiting reagent, and if yes, which one and what would be its mass? That is the question. Okay, so like this question is divided into three parts that we'll discuss one by one. Okay, the first part, what we say, calculate the mass of ammonia produced by this much grams of dinitrogen react with 1 gram of dihydrogen. Okay, let's see. Now when we say the first part, when we say here, you can see the reaction here, 1 it is written, so I can write 1 mole of N2 reacts with 3 mole of H2 to give 2 mole of NH3, right? Now if I convert this into grams, when we say, we can say N2, N2 means what? It is 2 into 14, which is equal to 28 grams, right? Hydrogen, when we say H2, H2 means what? Actually it is 2 into 1, but here 3H2 is there, right? So what I will do, I will multiply by 3 also, so it will be 6 grams, what we say, right? Means 28 grams, I can write here, 28 grams of N2 reacts with 6 grams of H2. Understood? To give how much ammonia? The ammonia, when you calculate, it is what? 17, when we say, that is 14 plus 3 into 1, right? But we know there is, how many moles are there? 2 moles are there. So I will write 2 into NH3, that is 2 into this 17, that is equal to 34 grams it will be. Understood? So when we write this part here, this will give 34 grams of what you call it as NH3, right? So we will start the first part by what is given in your book, that is, we can say, we can write easily, that is 1 gram, or we can directly write if you want, that is 28 grams, 28 gram of what I am talking about, N2 reacts with 6 grams of H2. Understood? So in your question, when we say what was given here, how many? 2000 grams of H2. So if I write N2, sorry, 2000 grams of N2 requires, we can write instead, require how much gram of H2, right? So therefore amount of H2 for 2000 grams of N2 is equal to, simple cross multiplication we will do like this. So it will be how much? It will be 2000 into 6 divided by 28 like this. Okay, now the next part. Okay, so if you calculate, it will be equal to 428.57 grams of H2. Understood? So 2000 grams will require how much? 428.57 grams of H2. Now here in the question it was given how much? 1000 grams is given here. Understood? So the next part, what is given here? So we can write that is 2000 grams of N2 reacts with, or requires, what we say reacts, or how much it is? Require. Reacts, or you can also write require 428.57 grams of H2. Understood? But in the question when you see 1000 gram is given, right? So we have actually 1000 gram of H2 is there, and if you compare this 1000 gram, this N2 is less, what we say. Understood? Means this is given in excess. So therefore from this only we can make out that H2 is in excess and N2 is limiting reagent. Understood this part? Okay, so H2 is in excess and N2 is limiting reagent, because for the 2000 only this much is required, but we have 1000, so obviously this will require more. So N2 is the limiting reagent. Okay, now the next part. Now from this equation you can see that is 28 grams of N2 will give 34 grams of what? Ammonia, right? So I can write here 28 grams of N2 gives 34 grams of NH3. Understood? So how much is given? 2000 grams was given of N2 gives, what we can say, how much grams of NH3? So therefore amount, or what is given in your book, mass of ammonia, amount, or you can also write mass of NH3 is equal to, you can see simple cross multiplication, that is 2000 into 34 divided by 28. It will be equal to, if you calculate, okay, it will be 2428.57 grams of H2 will be, NH3 will be produced. NH3 will be produced. Understood? So this is the answer for the first question what is given. Now second question was like this, that is will any of the two reactant will remain unreact? So which one which is in excess now will remain unreact? So we can write H2 is in excess, therefore it will remain unreacted. Understood? It will remain unreacted. Now the third question is there, what we can say, the third question is, if yes, if H2 is excess, what is unreacted? If yes, which one of would be its mass? What would be its mass? So we can say therefore amount of H2 remains unreacted. It's very simple. What you can do, 1000 was given in the question, that is 1.0 into 10 raised to 3 minus what we calculated, that is 428.57 grams. Understood? So if you subtract it, you will get 571.43 grams. Thus this is the answer for the third question. This is the answer for the second question, which one is excess. Understood? So this was the sum. Now the next one. Okay. The question is, how are 0.5 mole Na2CO3 and 0.50 molar, capital M, molarity, Na2CO3 is different. Okay. So now for this, first of all, we'll calculate the molar mass, right? Now when we calculate the molar mass, we can say molar mass of Na2CO3 is equal to, Na means 2 into 23 plus 1 into carbon 12 plus 3 into 16 of oxygen. So if you calculate this, the molar mass will be equal to 106 gram mole inverse. Understood? So we can say that 1 mole of Na2CO3 is equal to 106 gram of Na2CO3, right? Because whatever is the molar mass, that is equal to 1 mole. So if I write 0.50 mole of this Na2CO3 is equal to how much? So what it will do? We will do simple cross multiplication. So it will be therefore amount of Na2CO3 in 106 gram, sorry, in 0.5 mole, 0.5 mole is equal to simple cross multiplication, that is 0.50 into 106 divided by 1. So it will be equal to 53 grams, what we say. Understood? Means 0.5 mole is equal to 53 grams of what we call Na2CO3. Okay, now we are going to talk about 0.5 molar. Okay, next. Okay, now when we talk about 0.50 molar means we can say 0.5 mole of Na2CO3 we can write. Understood? Or simple, if 106 gram of Na2CO3 what we found, if you dissolve it in 1 liter, it gives you what? 1 molar solution. Understood? So if you say here instead of 1 molar it is 0.50 molar when we say, that will be equal to how much, what we say. So if you see, this will also be same only. See how it is, that is this simple cross multiplication will be there, that is 0.5 into 106 divided by 1. So we can say, therefore you can see amount of Na2CO3 in 0.50 molar is equal to, you can say simply you calculate, it will be also equal to 53 grams. Understood this part? Okay, so this is the part what we are talking about here. This we already discussed in molarity. Now the next question. Okay, you can see here, calculate the molarity of solution of ethanol in water. The word is what? Ethanol in water, in which mole fraction of ethanol is given. Mole fraction is given. Assume the density of water to be 1. Now this is the important part of this what I am talking about, right? The water to be, assume the density equal to 1, what we say. Okay, so now we'll continue with that. Now you can see 1.29, that is molarity. Molarity means moles of a solution, of a solute. Solute is here ethanol. Clear? In 1 liter of the solution, right? Molarity means, this is the definition. So we can say that is 1 liter of ethanol is dissolved. Ethanol is dissolved in 1 liter of water. So 1 liter of ethanol we can say is equal to 1 liter of water, right? Because you have seen density is 1 now. So therefore we can say number of moles of H2O in 1 liter, right? The 1 liter is equal to, 1 liter we can say is equal to, density was given. Density is equal to what? 1 gram is equal to 1 ml. Because you have seen in the question it was given here. What was the question? Assume the density of water to be 1. So here 1 it is, means 1 gram is equal to 1 liter. So 1000 ml is equal to 1000 gram divided by molar mass of water, which is equal to 55.5 mole. 55.55 mole what we got. Understood? So this 18 is what we say molar mass of water, molar mass of H2O, right? That is 2 into 1 plus 16, which is equal to 18 what we write. Okay, so we got moles of water here. Now we know for a binary solution, that is for a binary solution. What is binary solution means? With 1 solute and 1 solvent, we call that as binary. 1 plus 1 2, what we call binary solution. We can say there was a experimental data what you have seen, that is mole fraction of solute plus mole fraction of solvent is equal to 1, what we have studied, right? Now in your book mole fraction of ethanol is given, means x1 is equal to what we call mole fraction of ethanol I am talking about, right? So mole fraction of ethanol was given as equal to 0.040. In your question only it is given. So therefore what is x2? The x2 is mole fraction of water, what we say. Understood? So that will be equal to, we can write 1 minus x1, right? So which is equal, means here this is what we say, x2 will be 1 minus x1, this will go on the either side. So 1 minus x1 means 1 minus 0.040, so it will be 0.96. So mole fraction of water, mole fraction of water is 0.96, and mole fraction of ethanol means C2H5OH, is this what we say. Understood? Now the next part. Now the question was calculate the molarity. Molarity, the question was, what is the question here? You can see the question, calculate the molarity of solution of ethanol in water, means for ethanol you have to calculate the molarity. Okay, so that we are doing now, calculate the molarity of ethanol, right? So for that we can simply, first of all we know the formula, that is mole fraction of water is equal to moles of water upon moles of water plus moles of C2H5, that is ethanol. If you remember, we have written, if you know, that x2 is equal to n2 upon n1 plus n2, right? But I have written n2 first, what we say. Okay, so like this. So now if you see, substitute the value, mole fraction of water, I think we found out it was 0.96. Moles of water 55.55 divided by moles of water 55.55, and this moles of C2H5 will find from this data. Okay, this conversion what we say. So if you calculate, it will be 55.55. If you see here, it will be like this, 0.96, this part I will take here, that is 55.55 plus n C2H5OH is equal to 55.55, right? If you simplify this, you will get here 53.328 plus 0.96 n, means you multiply this like this, remember, a plus b. So here identity, you know, C2H5OH, which is equal to 55.55, right? Now this part I will take on the other side, so 0.96 and C2H5OH is equal to 55.55 minus 53.328, so which is equal to, if you subtract it, you will get 2.222, right? So 0.96 moles of C2H5OH is equal to this. So we can write now n of C2H5OH is equal to 2.222 divided by 0.96. So if you calculate this, I think you will get moles equal to 2.3145, right? And we know that is number of moles in 1 liter. In 1 liter is equal to molarity, right? What we have seen. So therefore molarity is equal to, we can write 2.3145 into what we say here, mole liter inverse, or 2.3145 molar, like this also you can write. Understood? Because this is the main part. Number of moles is equal to, means 1 molar solution means 1 mole in 1 liter solution, what we say. Okay, so this is the part what we say, this is your answer. Okay, now the next question. Okay, now this next question is 1.31. How many significants should be present in the answer of the following? So this is a homework for you, right? This question is a homework, right? Simply you have to calculate and significant figure you have to find. Understood? So this you can do it by yourself, because this already we have discussed in our previous video. Okay, calculate it and find the significant figure topic you can see, or the videos you can see of significant figure. Okay, now the next question 1.32. Using the data given in the following table to calculate the molar mass of naturally occurring argon, isotopes are there, Ar36, 38, Ar40. Okay, now this all isotopic molar mass is given and the abundance is given. Now there is a easy way to find, that is average we take out for this. Okay, so this we can calculate in a very simple way. You can see here 1.32 I am talking about. Okay, so when we say here, okay, question 1.32. okay, now if you see in that question, the percentage is given. So if you want to find molar mass, right, molar mass means we can use the word average molar mass of a argon, Ar, is equal to, what I will do, whatever was the percentage, that is percentage of the first one, that is Ar 36 I am talking about. It was 0. This percent symbol, it is 0.337% it is. So I will change it to 0.337 divided by 100. So it will be 0.00337. Okay, into, that is percentage into abundance. Abundance is over and isotopic molar mass. Molar mass, right? The molar mass is given 35 gram mole it is given, so 3596755. So that I have converted this, what we say, you can, sorry, 35 point it is. Okay, then plus 0 point, another one, 0.00 one more 067, because there is 0.67% was given, into the abundance. Now this one is for Ar 36. Now this one is for Ar 38 and another one for Ar 40. Like this you can add this all, multiply it and add. So here it will be 37.96272. Here it will be 0.9960, like this. So into, it will be 39.9624. okay, so if you calculate, it will be, this one will be 0.121 plus 0.024 plus 39.803, which is equal to 39.948 gram mole inverse. Understood? So this is all about what we are talking about, the molar mass, that is average molar mass of argon. All these three isotopes you have to calculate like this. The percentage abundance converted by removing the percentage symbol like this. If you remove percentage symbol, it will be upon 100. So like this we got this part. Okay, into molar mass, what is given, that is isotopic molar mass. Over. So this was the part. Now next question. Now these are the remaining three questions which are left out, that we will be doing it in next video. Okay, so we will stop here because this video is becoming lengthy. Okay, in next video we will be discussing about these three numericals. Okay, next time. Thank you.